All right, so we're going to be talking about fraction operations. We're going to start with adding and subtracting, and hopefully you remember that anytime you're adding or subtracting fractions, you're going to need to find a common denominator. When you're working with mixed numbers, that's when you have a whole number and a fraction. I like to change my mixed numbers into improper fractions first and then find the common denominator. So that's what I'm going to do. I'm going to start by multiplying. Some people call this Texas, some people call it around the world. Basically, you're multiplying 3 times 2 is 6, and then adding the 1. 3 times 2 is 6, plus 1 is 7, and you're keeping the denominator. I'm going to do the same thing on bottom. 4 times 1 is 4, add the 3, that's 7, and then keep the denominator. All right, so then my least common denominator is the least common multiple of 3 and 4. So I had a list of multiples of 3, 6, 9, 12. Okay, I'm looking for the multiple that they have in common. Well, 4, 8, 12, they both have 12 in common, so that's going to be my common denominator. So if I'm going to change this to a denominator of 12 and this to a denominator of 12, okay, what am I multiplying 3 by in order to make it 12? Multiplying by 4. If I multiply the bottom by 4, I have to multiply the top by 4. So 7 times 4 is 28. Okay, same thing on bottom. What times 4 gives me 12? 3. So 7 times 3, I'm going to do that on top, and I'm going to get 21. Right, I'm adding these together, so 28 plus 21 is going to be 49. Now the denominators I don't add, I keep those the same, 49 twelfths. Okay, so before you finish, you need to change your improper fraction back into a mixed number. So I'm going to divide, and again, we kind of talked about this briefly in the last video, but top in, bottom out, you're dividing 12 into 49. 12 will go into 49 4 times. And then I subtract and get a remainder of 1. Okay, so normally if I were working with decimals, I would add a decimal and keep going. When I'm working with fractions, then the 4, what I divide it, becomes my whole number. Okay, the remainder, the 1, becomes my numerator, and then the denominator is still the same. All right, so 12 will go into 49 4 times, that's the whole number. The remainder of 1, that's the numerator, and then the denominator doesn't change. So this is 4 and 1/12. Okay, you also want to check to make sure this fraction doesn't simplify at the end. 1 over 12 doesn't simplify, so I'm good. All right, same rules are going to be used with subtraction. I'm going to start by doing around the world or Texas or however you want to remember it. 5 times 3 is 15. Add the 2, that's 17 over 5. Over here, 10 times 1 is 10, plus 7, 17 over 10. Okay, so I'm looking for the common denominator of 5 and 10. If I do my multiples of 5, I get 5, 10, 15. Well, 10 is one of the multiples, so I only need to change this one into 10. So what do I multiply by 5 in order to make it 10? A 2, so I'm going to do that on top. 17 times 2 is 34. Okay, and then I still have the 17 over 10. It doesn't change since it already had a denominator of 10. Okay, this time I'm subtracting. 34 minus 17 is 17. I keep my denominator the same, so 17 over 10. This is improper, meaning the numerator is larger than the denominator. So I'm going to divide. 10 will go into 17, top goes in, bottom goes out. 10 will go into 17 one time. My remainder is 7, all right? And I'm not going to keep going because I want to make this back into a mixed number. So 1 is my whole number. 7, the remainder, is my numerator, and then my denominator stays 10. 7/10 does not simplify, so that's going to be my final answer, 1 and 7/10. Okay? All right, when you are multiplying fractions, you want to start by making mixed numbers into improper fractions. So if I do 5 times 2, that's 10. Add the 2, that's 12. I'm going to keep the 5, so 12 over 5. Over here, same thing. 4 times 1 is 4, plus 1 is 5. Over 4. Okay, and remember I can use the X for multiply. I'm going to use the dot mostly. And then after I change into improper fractions, I'm going to multiply the numerators, or we say top times the top, bottom times the bottom. So 12 times 5 is 60. 5 times 4 is 20. But then I need to simplify it. All right, so these are both divisible by 20. So 60 divided by 20 is 3, 20 divided by 20 is 1, and 3 over 1 is just 3. Now I do want to show you something. It's called what's it called? It's not called cross cancellation. I'm not thinking of it right now. But you can simplify before you multiply. So when I look at these numbers here, right, I can see that if the 5 and the 5, okay, are both divisible by 5. So another way to solve this problem, and this is going to be a great little shortcut later, is that these are both divisible by 5. So if I divide them both by 5, I get a 1 here. 12 and 4 are both divisible by 4. So if I divide these both by 4, I get a 1 here. 12 divided by 4 is 3. And then do top times the top, bottom times the bottom. What do I get? I get 3 times 1 is 3. 1 times 1 is 1, which is also 3. So you can do it either way. This is going to come in really handy later on, so it's nice to start looking for it now and getting used to using it. All right, dividing. When you change mixed numbers, again, into improper fractions first. So 1 times 3 is 3, add the 2, and that's 5 over 3. We're dividing it by 1 times 6 is 6, plus 5 is 11 over 6. Okay, so dividing, very similar to multiplying, except you have to remember to keep, change, flip. What that means is you keep the 5 over 3. Keep the first number the same. Keep, change, flip. So keep 5 over 3. Change, divide to multiply. Okay, and then flip to the reciprocal. All right, so that just means flip it over. So 6 over 11. Then you can multiply like you did earlier. Top times the top, bottom times the bottom. So 5 times 6 is 30. 3 times 11 is 33. And the last thing you want to do is check to see if this simplifies. These are both divisible by 3. So we can simplify it. 30 divided by 3 is 10. 33 divided by 3 is 11. And then this does not simplify anymore, so that's my final answer. Again, I could have simplified before I multiplied. So 5 and 11, okay, aren't divisible by the same thing, but 6 and 3 are. So 3 is divisible by 3. 6 is divisible by 3. So if I simplify those, 5 times 2 is 10. 1 times 11 is 11. So it just kind of saves you a step. Sometimes you don't have to work with bigger numbers. All right, so let's practice. But this time we're going to throw in some negative and positive numbers. So again, you're using those integer rules, but you're applying them to fractions now. All right, so when I have a positive and a negative, I'm actually going to subtract these. I still need to get a common denominator. I'm going to start by going ahead and finding or changing these to improper fractions first. So 6 times 6 is 36, plus 1 is 37. 4 times 8 is 32, plus 1 is 33 over 4, right? I need a common denominator. So if my multiples of 6 are 6 and 12, my multiples of 4 are 4, 8, and 12, then 12 is a common denominator. So what do I have to multiply by 6 in order to make it 12? 2. So I'm going to multiply this by 2 as well. 37 times 2 is 74. Over here, if I want to change the 4 into a 12, what do I have to multiply it by? I have to multiply it by 3. So that means I'm multiplying the 33 by 3 as well, so that's 99. Okay, and then this is where you have to pay attention to your signs. So I have 74 12s and 99 12s, but the 99 is negative. So I'm actually going to subtract, because my signs are different. So 99 minus 74 is 25. So that gives me 25. I keep the denominator the same, 12. Is my numerator negative or positive? Well, what did I have more of? The negatives or the positive? I had more negatives, so my answer is negative. But this is improper, so my last step is to go ahead and make sure I change this back. So dividing 12 into 25, it'll go 2 times, and I'll have a remainder of 1. So I'm going to rewrite this as with the negative. 2 is my whole number. 1 is my numerator. 12 is still my denominator. So negative 2 and 1 12. All right? And for this one, I have 3 fractions, so I can do 2 at a time. Or I can rewrite the whole thing at first. Since I'm using subtraction, remember I want to rewrite subtraction as addition. I use keep, change, change for that. So I'm going to keep the negative 3 and 1/2. I'm going to change this to add. I'm going to change 7/8 to negative 7/8. And then I'm going to do that again because this is also subtracting. All right, so I'm keeping my negative 7/8, changing to add, changing this to the opposite. So now it's 1 and 5/12. Okay, because I have 3 fractions here, I'm going to make them improper, and then I'm going to find a common denominator for all 3 of my fractions. So 2 times 3 is 6, plus 1 is 7, so this becomes a negative 7/2. This is already a fraction, so I don't need to make it improper. 12 times 1 is 12, plus 5 is 17 over 12. Okay, so if I want a common denominator between 2, 8, and 12, I like to look at the biggest one. I know my multiples of 12 are 12 and 24. I know that 8 times 3 is 24, and I know that 2 times 12 is 24, so 24 is a good common denominator. In order to change 2 into 24, I have to multiply by 12, so multiply it by 12. 7 times 12 is 84, and it's still negative. Okay, 8, I have to multiply by 3 in order to make it 24, so this is going to be a negative 21 over 24. And then to change 12 into 24, I have to multiply it by 2, so 17 times 2 is 34 over 24. All right, so once I have a common denominator, following my integer rules, I have 2 negatives, I'm adding 2 negatives, so if they're the same, I add them. 84 plus 21 is going to be 105. So this gives me negative 105 over 24, okay, but then I still have the 34 over 24. All right. Since these have different signs, now I subtract them. 105 minus 34 is going to be 71, right? And then because there are more negatives than positives, it's going to be negative 71 over 24. Okay, last thing I want to do is change this back into a mixed number. So I'm going to be dividing top and bottom out. 24 will go into 71. Let's see, 2 times 3. 3 times 4, yeah, 3 is too much. All right, so 2 times is 48. It's 11 minus 8 is 3, 6 minus 4 is 2. All right, so this becomes a negative, don't drop your negative. 2 is your whole number, 23 is your numerator, 24 is your denominator. Okay, and then that doesn't simplify, so that's my answer. All right, multiplying. I'm going to start by making my improper fractions. 3 times 5 is 15, plus 1 is 16. It's negative 16 over 3. This is not a fraction, but I can make it into a fraction by writing it over 1, 6 over 1. So I'm going to multiply times 6 over 1. Again, if I want to simplify before I multiply, sometimes that makes my multiplying easier. I want you to get used to seeing it this way, so I'm going to simplify first. I can't simplify 16 and 1, but I can simplify 3 and 6. Okay, these are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. All right, so now you do top times the top. 16 times 2 is 32. 1 times 1 is 1. And then a negative times a positive is negative. Anything over 1 is just the number, so negative 32 is my answer. All right, when you have 3 fractions, you can do 2 at a time. I'm going to rewrite these as a improper. 5 times 1 is 5, plus 4 is 9 over 5, and it's negative. And then this one's already written as a fraction, so I don't need to worry about it. 8 times 1 is 8, plus 3 is 11 over 8. Okay, this is multiplication, so I don't have to worry about common denominators. Again, I can simplify first. In this case, this is one of those cases where it's easy to see it is much simpler to multiply smaller numbers than to multiply several large numbers. So I'm going to look at just what I can do across. So the 5 and the 5 are both divisible by 5. So I'm going to go ahead and divide them both by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. And this is really negative 1 because it keeps the negative. 9 and 6 are both divisible by 3, so 6 divided by 3 is 2. 9 divided by 3 is 3. Okay, so this is really a negative 3. And then nothing really simplifies. The 3 and the 8 don't simplify. 11 and the 2 don't simplify. So now I'm just going to do the top times the top times the top. So a negative 3 times a negative 1 is positive 3. Positive 3 times 11 is positive 33. Okay, so you can just double check. A negative times a negative is positive. Remember your guy, negative times a negative is positive. And then positive times positive is positive. On bottom, 1 times 2 is 2, times 8 is 16. And then this is improper, so you're going to divide 16 into 33. It will go 2 times the remainder of 1. I'm going to rewrite this as 2. My remainder is my numerator, and 16 is my denominator. So 2 and 1/16. Okay? With division, again, we can write division as a fraction, but it just means divide. So if you want to rewrite this, you can. Negative 4 2/3, divide it by 1 1/6, if that makes you happy to write it that way first. And then you're going to change to improper. 4 times 3 is 12, plus 2 is 14 over 3. And this is still negative. I'm dividing by, go ahead and change this one too. 6 times 1 is 6, plus 1 is 7 over 6. And with division, I need to remember to keep, change, flip. So I'm going to keep the negative 14 over 3. I'm going to change division to multiplication, and I'm going to flip 7 over 6 to 6 over 7. Okay, because I want to cross simplify. All right, I'm going to look at the 14 and the 7. These are both divisible by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. It's negative 2. 3 and 6 simplify. 3 divided by 3 is 1. 6 divided by 3 is 2. So what I'm left with is negative 2 times 2, which is negative 4. 1 times 1 is 1. And then that's just the same thing as negative 4. All right, here it's just written as a regular division problem. So I'm going to go ahead and make them improper. 7 times 2 is 14, plus 4 is 18 over 7. It's still negative. I'm dividing by negative 1/4. So I'm going to just go ahead and do the next step also, which is keep, change, flip. So I'm going to keep this number, change to multiply, and flip the reciprocal to the reciprocal. So, and the negative can just stay with the numerator. That's where I like to keep it. And now I'm going to look to see if anything simplifies. So notice the 7 and the 4 do not simplify, and the 18 and the 1 do not simplify. So in this case, I just have to multiply like normal. So I would do 18 times 4, which is 72. And then 7 times 1, do the bottom times the bottom, which is 7. A negative times a negative is what? Positive, so I don't need to worry about that. And switch this back to improper. So if I divide 7 into 7, it goes 1 time. Oops. Bring down the 2. 7 will go into 2. 0 times. So a remainder of 2. So now my answer is 10. My remainder is my numerator, and my denominator is 7. So 10 and 2 7ths. All right. So that's fraction operations. So same operations you've seen before. We're just going to add integer operations with those as well. All right, see you soon.